So first off, I want to say congratulations to anyone who has been accepted into a physics program for fall. That's honestly amazing. Physics is one of the best subjects there is. One of my professors used to call it the mother of all sciences. And honestly, I would not change a single thing. I would always want to study physics no matter what. Now, in this video, I'm going to be going over some of the things you can expect to happen while you're studying physics, and basically go over what'll be going on in your studies of physics. So let's get into the video. So first off, if you have no idea what physics really is, a brief description of it is basically the study of how the universe works. So how planets orbit around the solar system, how atoms store charge and how charges move, and what magnetic and electric fields do, things like that. So physics is basically the mechanics of the universe. Now, hopefully you have taken some sort of high school level physics or AP physics or something like that, so you have a relatively general understanding of what classical physics is, or Newtonian mechanics is, F equals ma, Newton's second law, stuff like that. Basically, in your first year of physics, you're going to be taking courses just like that in Newtonian physics, along with electricity and magnetism, and a little bit of modern physics, so some special relativity, nuclear physics, thermodynamics, things like that. And these courses are actually particularly tough because, number one, you're fresh into college and you're at the expectation of a next higher level education. So it's way beyond what you would have learned in even AP physics, honestly. And the reason they make these courses really tough is because these are general physics courses, because everyone takes these, whether they're biology, med school students, physics students, engineers. So these courses have to be tough so that everyone in all disciplines have a large understanding of what physics is and how they can use it in their certain applications. Because if an engineer doesn't know Newton's laws very well, then the bridges they build are just gonna collapse, and if doctors don't know things like fluid flow or anything, they might not fully understand how blood flows through your veins and arteries and all that. So the first year is gonna be particularly tough because, one, you're going into a brand new system, and two, because the classes are designed to be harder than normal, especially harder than normal lower division classes. Whereas if you were to take a lower division English and everything, those are much easier than the upper divisions. Whereas these lower division classes are probably pretty on par with the expectations of upper division classes. Besides, upper division classes have more fancy mathematics or more advanced mathematics. So while you're taking your first few general physics classes, you'll also be taking your few general education classes. Now these classes are basically your liberal arts classes, or your English, your history, political science, things like that. Now, I went to community college, so I took all these at community college, and I'm probably gonna make a video on that soon, so make sure you like and hit subscribe to get ready for that video about my transfer experience. But these lower division classes are gonna be basically much easier than your physics classes. If you've seen the TikTok of the guy that's STEM students and general education classes, or some guy rambling on about something, that's 100% very accurate. But that does not mean they're not important, because like everything, you can learn a lot of different things from these classes. So you can actually learn study skills, good habits, good note-taking skills from just these classes as well. So don't think they're a waste of time, because they're not. They can actually teach you a lot about how college works, and the whole career system and everything, and note-taking and productivity skills, all that kind of stuff. Now also, these first general physics classes will probably be pretty boring to you. Even as a physics major, someone who loves physics, no one gets super excited about Newtonian mechanics or conservation of motion, or conservation of momentum, I mean, or things like that. But these are fundamentals that you need for upper division physics to get into the more fun stuff, to be able to understand it and appreciate it much more. Now, maybe towards the end of your second year or your third year, you're going to start taking your upper division courses, which are the fun courses, your quantum mechanics, your electricity and magnetism, your thermodynamics and statistical mechanics. These are the classes that are fun and are the ones that get physics majors excited. Now, obviously, my favorite is quantum mechanics, The channel is called Quantum Victor for a reason. But with quantum mechanics, it's now obviously my favorite is quantum mechanics, obviously. So let's go over what you can expect in quantum mechanics first. You might think it's going over like Schrodinger's cat and many worlds interpretation and all that kind of stuff, but really, quantum mechanics is actually a very heavy mathematical subject. You're basically going to be introduced to the Schrodinger equation, solve this partial differential equation different ways for different systems and different potentials. You'll find out what that means when you take the class, but basically what you're doing is solving a differential equation, which you should take differential equations before almost any other upper division physics class. So let's go over the math classes that you want to have. You want to make sure you can take calculus as soon as possible. Calculus 1, Calculus 2, multivariable calculus, and vector calculus. However your school splits them up, make sure you take all of those as soon as you can, and pay really close attention into all of them, because calculus is the fundamental theory and mathematics of physics. I can't stress this enough. Make sure you pay close attention in calculus. I kind of lagged off a little bit in my vector calculus class, and my E&M courses were so much harder than they should have been. Now, on top of all your calculus classes, you're going to want to take what's called linear algebra and differential equations. These two classes are basically matrix mechanics and linear algebra, and differential equations is kind of like calculus, except splitting it up into differential equations, like taking equations with derivatives inside of them. In linear algebra, this is very fundamental to a lot of quantum mechanics, and even going into higher level classical mechanics, like Newtonian mechanics, rotational dynamics, and things like that. So you're going to want to know a lot of solid matrix mechanics to do this. Differential equations is probably the most important class, or at least the most important math class you can take, because literally everything inside of physics is the differential equation, which again is just an equation with a derivative inside of it, and you're just solving for whatever equation the derivative is taken respect to. For example, the easiest thing to do is separation of variables. I'll put an example on screen, and that's basically the easiest thing you can do in differential equations. You probably learned that in Calculus 1, but you find much harder ones and much more non-trivial solutions to these differential equations, and every single thing after that in physics becomes a differential equation. Newton's second law, the Schrodinger equation, every single other equation, basically, it all becomes differential equations. And along with your lower division courses, you also have labs associated to them. So you might do experiments like rolling balls down ramps and crashing cars into each other, which are pretty fun actually. I enjoyed the lower division labs because they actually show what you're learning, whereas in upper division physics, you don't get labs associated with the class. You kind of have to just use your imagination to see what things are happening. Now, another one of the first upper division physics classes you're going to take is either mathematical methods or complex variables or complex analysis. Every class, every university calls it something a little different. It's basically a class on what kind of math you need for upper division physics. So doing more differential equations, complex analysis, and complex variable solving, Green's functions, gamma functions. These things probably have no no interest in your brain right now, but you're gonna need them for higher level physics. So I didn't really use a lot of this stuff until maybe Quantum 2 or Quantum 3 and StatMech, but they're really important to learn because things like contour integration come back time and time again once you get into the high levels of physics. Now, if you are interested in astrophysics, I am not 100% sure on what astrophysics courses are going to be offered at your particular university, but I can guarantee you there will be something similar to planetary structures in orbit, general relativity, and then stellar structures and things like that. So there's probably going to be something like that for you. Me personally, I actually took an astrophysics course in observational astrophysics, which was a lab actually, where we actually like sent requests to a telescope to take pictures of the sky, and we like did some like weird research on stars and learned just how to like take pictures of stars basically. So that was my astrophysics experience. I just took pictures of stars, which was super fun actually. So yeah, every school has something a little bit different. Whether it be general relativity, learning about like the space-time continuum and Einstein's equations, or stellar structures, learning about how stars live and what kind of stars there are and different things, or like planetary motion, like finding exoplanets and things like that. I don't know. I honestly don't know much about astrophysics actually. Neil deGrasse Tyson, I don't know. Okay, here's one that I probably should have covered at the beginning, is your advanced classical mechanics courses. So at UCSB we had two of them. We had classical mechanics and advanced mechanics. Some places combine those two into one. I think it's kind of nice having two actually, but basically the first one I took, the classical mechanics, is just basically the hard problems from your general physics course, at least in like the classical mechanics realm. So Newton's laws become differential equations. You now find like a lot of different friction forces, like quadratic friction and like static friction and all that. Lots of different forces acting on different things basically, and special relativity. You go more in depth into it. Now advanced mechanics is really where you get into the fun, heavy, advanced mechanics is where you get into the real fun and heavy classical mechanics stuff. This is where you learn Lagrangians, Hamiltonians, moment of inertia tensors, all this fun stuff that you've been waiting so long to learn about basically. Even if you've probably never heard of it, it's actually like so fun to learn about. I love Lagrangian and Hamiltonian mechanics, so I love that class a lot. In fact, I was also introduced to nonlinear mechanics in this class for an extra credit project, which is how I got so into nonlinear mechanics and took a whole separate course on that, but I'll talk about that in electives. Next comes electricity and magnetism. This was my worst class and the hardest class for me, I'm not gonna lie. It was tough. So basically this class is just basically vector calculus and Calc 3, but applied to physics, which is like the application of these things to charges, static charges, steady currents. So you're finding electric fields, magnetic fields, how they interact, how they change, how all these kinds of different things. My course was broken up into two. One where we did like the steady state single charges, or like steady charges, and the steady currents where they're not changing, and then one where we did the changing stuff and applied it to, you know, what visible light waves and waveguides and all kinds of different stuff. It wasn't fun. I'm not gonna lie, that one was not fun for me, especially when we got into special relativity with these things. But now that the hard stuff is behind us, let's go into thermodynamics, which thermodynamics is basically the study of how energy is transferred between systems. So the most notable system is like the car engine, the piston combustion engine, how the pressure and volume changes and creates a transfer of energy from the chemical potential energy in the gasoline to mechanical rotational energy in the piston and the crankshaft. That's the most classical example. You can apply this to literally anything else, like baking food in an oven or like on a pan, or even like how computer electronics work, like the heat transfer inside there. Everything is basically a thermodynamical system. And you start on this macroscopic scale, and as you shrink down and down into like looking at more individualized things, that's when you get to what's called statistical mechanics or ensemble mechanics theories. And this basically just takes thermodynamics and adds like a statistical interpretation to it. And statistical mechanics is basically one of the most fundamental theories of physics. It is very accurate and very well defined, that it's really honestly one of the most important things you can learn. UCSB had it as an elective, but I chose to take it for fun, and it was actually very, very hard. The mathematics in statistical mechanics is hard. You want to make sure you pay attention to your mathematical methods classes. But that was probably one of the most satisfying classes I've taken because of how much I learned from it. And finally, let's get into what kind of labs you can take. So basically, every physics student takes an analog electronics lab or something similar to that, like applied physics lab or something like that. This is where you're going to be working with circuits. Circuits are honestly so fun. I really enjoyed it as well. And you're basically going to be building circuits, designing circuits, figuring out how transistors work and like how to put in capacitors and all diodes and all kinds of stuff into circuits and making something work. And at the end of my class, or towards the end of my class, we built an FM radio, which was pretty cool, I guess. And then we had a project where we just designed whatever we wanted at the very end. But yeah, this was one of the most fun classes I took. I actually really enjoy more like applied physics stuff, actually, too. And to preface this, I actually fully enjoy applied physics way more than theoretical physics and like the mathematics of going through things and all that. So being in a lab like that is actually super enjoyable to me, but some other people might like just, solving equations a lot more because they find it more satisfying to solve an equation they've been working on so hard instead of plugging in a resistor into the wrong thing for the 100th time. Now, on top of that, I took a digital electronics class, which was the continuous course of the analog electronics class. And in this one, we actually did some like computer-based logic programming. So we did like very low-level VHDL, FPGA programming, which is like the base logic of how computers work. So like we did things like AND gates, NAND gates, OR gates, XOR gates, and then went into things like flip-flops and all kinds of stuff and found out how memory works and RAM works and all that kind of fun stuff. So that was actually super fun. I really enjoyed that class. I feel like I'm just saying I enjoyed all my classes except for E&M. E&M I did not enjoy. So it is okay to not enjoy all your classes. And last, instead of a senior thesis, my school had me do a senior lab. So our senior lab basically just went through all the kinds of famous physics experiments that we did, like the double slit experiment we recreated. We recreated some other, like the photoelectric effect and things like that. So yeah, that was my senior lab. It was kind of just recreating the very iconic physics findings. Now let's get into electives. The one elective I 100% recommend everyone should take is either computational physics or like Python coding or something like that, so that you can learn how to code in like Python or C++ or Java or something like that. Almost all of physics nowadays is basically done on a computer. There's no one's actually like solving these equations anymore. It's all done computationally. So if you can learn to do these computations on a computer by taking the computation physics courses or something like that, or programming for physics it might also be called, you should 100% look into taking that because I highly recommend. And then you'll probably have more electives like general relativity. So there were more advanced E&M courses that I did not want to take. There are some more advanced like thermo courses, continuum physics, what else was there? Solid state physics, basically like condensed matter stuff. There are all kinds of courses for all kinds of different things, so just look into what ones you think you want to take. Like I said, my electives were observational astrophysics, computational physics, nonlinear dynamics, and statistical mechanics, and digital electronics. Those were my electives, and honestly, I don't regret taking any of them. They were all very interesting to me. Now, with all these classes, you can expect to study a lot. You should definitely get used to studying way more than you think you're gonna need to, because I promise, I promise, you're going to have to study more than you do now. You might have been able to get away with not studying as much so far, or not studying at all, honestly, but everyone gets to a point where you can't just like look at something and learn it and understand it anymore. You have to continuously review and learn and try to learn new things by studying and trying and trying and trying. Physics is not an Physics is not an observer's sport, as one of my professors said. You have to do it yourself, and you have to do it a lot. That is how you get good at physics, is by repeatedly trying. And if you want more study tips on that, I have a video up here that you can watch for study tips on physics. And that's basically it. Thank you for watching the video. Like if you enjoyed it, and subscribe because I have future videos coming out for what physics is like and productivity tips for STEM students. So click like, subscribe, and I'll see you in the next video. Bye.